Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 Strength, Dispersion and Cracking Characteristics of Locally Available Marine Soil as a Landfill Liner K. Nanditha Superscript 1, J. Harikrishna Menon Superscript 2, Muneeba Muhammed Iqbal Superscript 3, Nazrin VA Superscript 1 Superscript 2 Superscript 3 UG Students, Department of Civil Engineering ADI Shankara Institute of Engineering and Technology, Kalidi, India Abishek Kumar AA Assistant Professor, Department of Civil Engineering ADI Shankara Institute of Engineering and Technology, Kalidi India Abstract. In a developing country like India, a huge amount of waste is produced daily due to human activities. This waste needs to be properly disposed as it can cause high risk and can affect human life when it gets in contact with water and other such resources. Landfilling is a method used to dispose waste that requires only less investment unless a suitable area is found. In landfilling, liner is used on the bottom to prevent the leachate migration to the groundwater. Landfill liner can be constructed using different types of materials. Using locally available materials would make it cost-effective. Locally available marine soil is used for liner construction. Marine soil is mixed with additives such as fly ash and polypropylene in different proportions to increase its liner properties, and the best mixture of this proportion is found. The tests are done to find the strength, dispersion, and cracking characteristics of the liner material. Keywords: landfill liner, marine soil, dispersion, crack. Introduction: waste disposal is a difficulty faced by all. If it is not properly disposed, it can cause health issues to all living things. There are different methods of waste disposal, among them one is landfilling. Traditional ways of waste disposal are open dumping. But it leads to many environmental issues. So we need an effective method of waste disposal. Landfilling is a method that we commonly adopt nowadays, in which wastes are buried. Since the wastes are being buried, there can be migration of chemicals to underground water, which contaminates the water and makes it non-useful. Contamination of water leads to many health problems for both human beings and animals. It can also affect aquatic life. To prevent underground contamination, liners are kept on the sides and the bottom side. A landfill liner is a low permeable barrier that can prevent the percolation of leachate water. A good liner should have less dispersion and cracking characteristics, strength, minimum gravel content, maximum fines content, and hydraulic conductivity of less than 10 to 7 cm/s. Liners can be created with different materials and they are high in cost. The commonly used landfill liner materials are compacted clay, geosynthetic clay, geomembrane, geotextiles, geonet, and geogrid. This study is to make a cost-effective liner by taking locally available soil as the liner material. The soil taken for this study is marine soil. To improve its strength characteristics, additives such as fly ash and polypropylene fiber are added to it. Initial property testing is done on both fly ash and marine soil. For strength property testing, fly ash is taken in 0%, 10%, 20%, 30%, and 40%, and polypropylene fiber is taken in 0%, 0.25%, 0.50%, 0.75%, and 1.00%. The best mix is found out using various tests. Using the best proportions, both dispersion and crack have been analyzed too. Material properties: A. Marine soil samples are collected from the Cochin shipyard. Dredging was carried out there for dry dock construction. Marine soil was collected from there at a depth of 25-30 m. The soil in this region is black-colored, highly compressible soil with high organic content. The soil was dried and sieved. Table 1. Properties of marine soil. Properties: specific gravity values 2.54, liquid limit, %. 46 plastic limit, 22.1 flow index, optimum moisture content, %. 30.59, 21 maximum dry density, Kn/m3, 10.66 coefficient of curvature, 2.023 uniformity coefficient, 8.84 unconfined compressive strength, Kn/m2, 77.89 permeability, cm/sec, 1.09 x 10-5. IJERT 10 is 060145 www.ijert.org 642. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021. B. Fly ash used in this study was collected from ready mix plant at AR, Ernakulam. Fly ash is a waste produced from coal-fired power generating stations and is readily available inexpensively. In this study class, fly ash is used. Table 2. Properties of fly ash. Properties: specific gravity, liquid limit, %. Flow index values 253.5 45.55 conducted. Effect of fly ash on the unconfined compressive strength of marine soil is as follows. Table 3. Variation of UCC on fly ash content 0%, 10%, 20%, 30%, 40% UCS, KN/M2, 77.89 96.65 100.3 92.9 83.85 Coefficient of curvature 1.36 Uniformity coefficient 4.7 C Polypropylene. Polypropylene is the most common synthetic material used to stabilize soil and concrete. This material has a relatively low cost. By blending the fibers with mineral components, the strength and the applicable temperature range of the component are extended. For the study purpose, it is collected from an online source. 3. Experimental program A. Sample preparation. Samples are prepared by mixing marine soil with fly ash and polypropylene. Firstly, marine soil is mixed with the fly ash, where the fly ash content is 0%, 10%, 20%, 30%, and 40% by the weight of the soil. Then optimum fly ash is fixed based on strength test results after selecting optimum fly ash content, 0%, 0.25%, 0.50%, 0.75% and 1.0% polypropylene is added to the above optimum fly ash mix and optimum polypropylene percentage is found out using strength test values. Dispersion characteristics for the selected soil fly ash mix are tested. The sample preparations and conducting experiments are done according to ASTM and IS specifications. Unconfined compressive strength crumb test. Double hydrometer test. Crack analysis using ImageJ software. 4. Results and discussion. A. Unconfined compressive strength test. 1. Effect of fly ash. Take a sample of soil and then add different percentages of fly ash and then strength tests are Fig. 1. Strain curve for soil with different fly ash content. The UCC value of marine soil increases with increase in fly ash content up to 20% fly ash content and then decreases. 2. Effect of polypropylene. The optimum content of fly ash was found as 20%. Take a sample of soil plus 20% fly ash and add different percentages of polypropylene. Strength test was conducted and the optimum percentage of polypropylene was found. Table 4. Variation of UCC on different polypropylene content. PP fiber content UCS, KN/M2, 0%, 0.25%, 0.50%, 0.75%, 1.00%, 100.3, 103.26, 130.08, 132.9, 119.12 IJERT 10 is 06015 www.ijert.org 643. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 Table 5. Dispersivity if various mixes. Sample type. Soil time 2 minutes 1 hour 6 hour. Grade 234. Dispersivity intermediate dispersive highly dispersive soil plus 20% fly ash 2 minutes 1 non-dispersive. Fig. 2. Strain curve for soil plus 20% fly ash with different polypropylene content. B. Dispersion test. 1. Dispersion characteristics based on crumb test. The crumb test gives a quick indication of the depressiveness of soil. The crumb test was carried out as per ASTM standards. A sample of 15 mm cubes was prepared. Sample compacted according to its maximum dry density and optimum moisture content. Visual observations are made at 2 minutes, 1 hour, and 6 hours. 1 hour 2 6 hour 2 intermediate 2. Dispersion characteristics based on double hydrometer test. Fig. 3 soil at 6 HOURS. Fig. 5 double hydrometer test result for soil. Fig. 4 soil plus 20% fly ash at 6 HOURS. Fig. 6 double hydrometer test result for soil plus 20% fly ash. C. Crack analysis. 3 molds were taken in which one is filled with soil samples. The second is filled with soil plus 20% fly ash and IJERT 10 is 06015 www.ijert.org 644. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021. The last is filled with soil plus 20% fly ash plus 0.75% polypropylene mix. Then the samples were kept at room temperature for 7 days. Pictures of crack formation in each sample were taken after these 7 days and analysis is done using ImageJ software. Table 6. Crack length, width, and crack intensity factor of soil with various proportions of fly ash and polypropylene sample. Crack length average width crack intensity, mm, factor, percent. Soil 389 0.9784.84 soil plus 20% fly 305 ash 0.8613.34 soil plus 20% fly 89.384 0.588 0.67 ash plus 0.75% polypropylene fig 7 crack of normal soil fig 8 crack of soil plus 20% fly ash fig 9 crack of soil plus 20% fly ash plus 0.75% polypropylene crack length and width get reduced by adding 20% fly ash and 0.75% polypropylene. V. Conclusion: the strength, dispersion, and cracking characteristics of soil amended with fly ash and polypropylene fiber were studied. The major conclusions drawn from the present study may be summarized as follows. The optimum percentage of fly ash was found to be 20% and that of polypropylene fibers to be 0.75%, based on strength characteristics. The addition of fly ash causes a significant decrease in the dispersion and increase in strength characteristics. Dispersivity of soil is greatly reduced by the addition of fly ash. Crumb test results show that the dispersion of soil can be reduced by the addition of fly ash. Crack when tested by ImageJ software, soil plus 20% fly ash plus 0.75% polypropylene showed reduced crack width. References 1 Basrat Gisaligada and Satyendra Mittal, Improving the Characteristics of Dispersive Subgrade Soils Using Lime, published by Elsevier Ltd., accepted February 4, 2022. Sanan Marabja, Gassam Hababagahi, Esan Nikui, and Alinisa Stabilization of Dispersive Soils by Means of Biological Calcite Precipitation, 2017. Elsevier, accepted November 26, 2017. 3 Abishek Kumar A.A., Haritha R. Nair, Megha Mohanan Rivati Daskutan, Rosman K. Jose, Strength and Dispersion Studies in Compacted Liner Soil, International Journal of Science and Research, IJSR, ISSN, Online 2319-7064 Index Copernicus Value, 2013, 4 Sheila Joseph. A. and Megha Varghese, Study on Amended Landfill Liner Using Bentonite and Zeolite Mixtures, International Research Journal of Engineering and Technology, IJERT, Volume 4, Issue 4, April 2017. 5 Chao Shengtanga, Qingqinga, Tinglenga, Benxia, Hao Zhenga, Hilary Ianyang, Effect of Wetting Drying Cycle and Desiccation Cracks on Mechanical Behavior of an Unsaturated Soil, Katina 194, Elsevier, May 2026. Chao Shengtang L, Chengzhu, Tinglen, Qingchen, Haozhen, Benxi. 3-dimensional characterization behavior of compacted soil using X-ray computed tomography, Engineering Geology 255, 2019, 1-10, Elsevier, April 2019. IJERT 10 is 060145 www.ijert.org 645. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 7 Yang L, Saihong Liu, Liping Wen, Liujiang Wang Zhou Leisu Fractal Analysis of Cracking in a Clayey Soil Under Freeze-Thaw Cycle, Engineering Geology 208, 2016, 93-99, Elsevier, April 2016. 8 Abishek Kumar A. Mira Manuel Strength and Dispersion Studies in Compacted Liner Soil International Journal of Science and Research, IJSR, 9 Hania Baslu, Hojade Hadifard, Ali Reza Ghanizadeh Effect of Cations and Anions on Flocculation of Dispersive Clayey Soils, published by Elsevier Ltd. Accepted 19, February 2020. Tenlei Li, Chenlin's Higangjiang Utilization of Shale Clay Mixtures as a Landfill Liner Material to Retain Heavy Metal, Made, 2017. IJERT 10 is 060145 www.ijert.org 646. This work is licensed under a Creative Commons Attribution 4.0 International License.